example 4, we're going to multiply mn plus 1 times mn minus 2 times mn plus 4. So we have 3 different binomials being multiplied. So mn plus 1, 2 terms, times mn minus 2, 2 terms, times mn plus 4, 2 terms. Now, what we learned yesterday was in order to multiply polynomial times polynomial, we're going to multiply, let's say I'm multiplying these first 2 polynomials here, these 2. I'm going to take the first object times everything, and then the second object times everything. So that's what I'm trying to do here. So looking at that, I would do, this is mn, I'd multiply that times mn minus 2, and that's plus 1, I'm going to multiply that times mn minus 2. While I'm doing this, I am ignoring this. It's still part of the problem, but I don't care about that when I'm working out that part of the problem. So I'm just multiplying one times another. Doesn't matter which 2. I just picked these 2 because they're in the front. I could have picked those 2 because they're in the back. Doesn't matter which 2 you pick. Just multiply 2 of them together using the technique we saw yesterday. And then I'm going to multiply mn times mn, which makes m squared n squared. Remember, when you're multiplying letters, the powers that get added together. M and n are both to the first power there, so m to the first times n to the first makes m squared. 1 plus 1 is 2. N to the first times n to the first makes n squared because 1 plus 1 is 2. When I multiply mn times negative 2, I simply get negative 2mn. Then I have plus 1 in front of this. I'm going to multiply plus 1 times mn. I get plus 1mn. And I do plus 1 times minus 2. I get minus 2. In each case, multiplying the signs match. I get a positive. If the signs are opposite, I get a negative. Positive is addition. Negative is subtraction. So I get positive m squared of n squared. Subtract, so minus 2mn. Add, so plus mn. And then subtract minus 2. If I combine my like terms, which you'll notice that these 2 guys here are like terms. They both have m to the first, n to the first, so addition is legal. I'm going to get my m squared n squared, which has the wrong power, so I can't add that with anything. Negative 2 plus positive 1 makes negative 1, and I'm going to get mn. Remember, when we add like terms, powers do not change. And I'm using add in the algebraic sense. I either add or subtract based on signs. These signs are different, that's why I subtracted. And then minus 2 has no like terms. So this trinomial expression, 1, 2, 3 objects, is the product of these 2 guys up here. That product is being multiplied by mn plus 4. So now I'm going to bring mn plus 4 back into the problem. So again, I've just kind of put it on the back burner. It's part of the problem, but I wanted it out of the way while I was working that out. Now that I've worked that out, I want to bring it back into the problem. And now it's the same exact kind of problem we just solved. We have object 1, m squared n squared, going to be multiplied by mn plus 4. We have negative 1mn being multiplied by mn plus 4. And we have a negative 2 being multiplied by mn plus 4. Every object in the first polynomial multiplied by the second polynomial. This time there's 3 objects, so we get 3 multiplications happening. Each one of these, black, red, and green, is a distributive property scenario. So I'm going to take m squared n squared times mn and m squared n squared times 4. That's going to give me m cubed n cubed plus 4m squared n squared. Again, I'm multiplying letters. M squared times m to the first makes m to the third because 2 plus 1 is 3. N squared times n to the first makes n to the third because 2 plus 1 is 3. We're adding powers of the same letters. When I multiply 4, positive 4 times m squared n squared, they're all kind of different kinds of things, so just stick them together. In the past, I've said use the Lego rule. Think of the m squared, n squared, and 4 as Legos, and you're sticking them together. You got a green, black, and a red Lego stuck together. But it's just, they're all different kinds of things. They can be multiplied together, but it doesn't change anything. 4 is still 4, m squared is still m squared, n squared is still n squared. You just get that term.
So why can't we have, well, the plus 4, why wouldn't the m and n be cubed?
Because there's no m and n on 4. So here, when I multiplied m times m, I had to do 2 plus 1 to make a third power. There's no m's over here to change the powers of m and n.
So you add those?
You just, I'm multiplying m squared n squared times 4.
Oh,
So just sticking them together. So they're all being multiplied, but they're different types of things. So all you can do is put them together. You can't actually modify anything.
okay.
If there was a number here, like if this said like 3m squared n squared, 3 times 4 makes 12, you make a modification of the number because they're the same kind of thing. They affect each other.
Yeah.
But when you have different types of things, all you can do is stick them together. All right. Next, I've got negative 1mn. I'm going to be multiplying times mn plus 4. So negative 1mn times positive 1mn. Opposite signs gets me minus. I'm going to get m squared n squared again. They both have m, they both have n, so we add the powers. 1 plus 1 is 2. Negative 1mn times positive 4 makes negative 4mn. And again, that's what happened there. 4 and 1 makes 4, right? And then mn. And then finally I got minus 2 being multiplied here. Minus 2 times mn is going to be minus 2mn. And minus 2 times positive 4 is going to be minus 8. Right. So again, I simply apply the distributive property there. Got 6 products out of the whole thing. And my final step then is to combine like terms, if there are any. 4m squared n squared and negative 1m squared m squared are like terms. They both have m squared n squared. Negative 4mn and negative 2mn are like terms. They both have m to the first, n to the first. Nothing else is m cubed, n cubed. Nothing else is a constant. Those are not like with anything. So my final result is going to be m cubed, n cubed. Right here, these signs are opposite. 4 minus 1 is positive 3, m squared, n squared. These signs are the same, so I add, I get negative 6, mn. And then minus 8 is just minus 8, and there is the simplified expression. So a lot of multiplication happening in this, and I need you guys to have really good focus when you're going through this to make a distinction between multiplying things. When the coefficients multiply, the powers add. So we change powers when we're multiplying. Then we get to the addition subtraction phase of the problem. We're combining like terms. We're adding or subtracting the coefficients, and the powers do not change. Most people who mess up on this, they'll be combining these two things together here, and they just got done doing mn times mn makes m squared n squared. They're doing mn plus mn, and they want to make m squared n squared also. So be careful that this is an addition subtraction step, powers do not change. This is a multiplication step, powers do change. So be careful of that distinction. That'll help you to get the right answer on these. Now the last thing I asked for is the degree of the product. So we dealt with degree yesterday. It's the same as it was yesterday. We find the degree of each term. We add the powers of the letters in the problem, right? So this m cubed, n cubed, if I look at that object, the letters are m and n, the powers are 3 and 3, 3 plus 3 is 6. So the degree of the blue highlighted term is 6. Right here, the powers are 2 and 2 for m and n, so 2 plus 2 is 4, so 6, 4. The powers of m and n there are 1 and 1, 1 plus 1 is 2, so that's 2. And finally, this has no letters, so its degree is 0. So we have degree 6, degree 4, degree 2, degree 0. The degree of the polynomial is 6.